Hey there guys, this is the notes videos for Notes Radicals, day 2 of Radicals. So in here we're going to do the same thing we did last time, except we're adding an extra thing, which is we're multiplying radicals now. Now the way to multiply radicals is, if both terms are radicals, then you can multiply the numbers under the radical sign. For example, if you have square root 5, which reminder, radical just means the square root symbol, square root 5 times square root 3. Since they both have square roots, you kind of consider them like terms. So you can multiply 5 times 3, which is 15. And then you'll keep the square root. So square root 5 times square root 3 is just square root 15. But you cannot multiply them if they're not like terms. For example, if one of them is a radical, but one of them is not. Square root 5 times 3 is not square root 15. Instead, you will just leave it like 3 square root 5. These do not multiply. You'll just rewrite them so that the coefficient or the whole number is at the front and the radical is going afterwards. Kind of like writing 3x, 3y, whole number goes in front, then the variable. If there's a mix, for example, if you have whole number 2, radical 5 times 3 square root 2, well, in this case, what you're going to do is you're going to multiply your whole numbers first, so your like terms, the non-radical with the non-radical. 2 times 3 is 6, and then you will multiply your radical by your radical. Square root 5 times square root 2 is square root 10. So your answer is 6 square root of 10. So here we have some example problems. So we look at the first one, which says, okay, 3 square roots of 4. We have to simplify this radical. Now, this is also what we learned last class. Now, you might notice there's nothing being multiplied, but we can simplify this radical on the inside. So, you know that square root 4 is really 2. The square root of 4 is 2. So if you don't remember your perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on and so forth. So if you don't have these memorized, it might be helpful to have them on the end, because then you would notice, hey, square root 4 is a perfect square, which will give you 2. But we still have this 3 here. Now our answer isn't 32. These are actually being multiplied. Same thing as 3x really means 3 times x. 3 to square root 4 really means 3 times square root 4. Kind of like this. But the reason this time we can multiply and we couldn't multiply here is because square root 4 is really 2. The square root of 4 is 2. Which is 6. Because 3 times 2 is 6. Now, sometimes you can double check your answers. So if I notice in my calculator I do 3 square root 4, notice it gives you a whole number 6 back. This won't always work because if you have, for example, if you had done 3 times square root 5, it would give you a decimal value. Now, let's look at this one. 2 times square root 25. Notice 25 is a perfect square, and it's the perfect square of 5. So the square root of 25 is whole number 5. And then you bring down your whole number 2 that's still on the outside. So you get 2 times 5, which is square root of 25. So notice 5 squared is 25, and the square root of 25, you get back to 5. That will just give you 10, because 2 times 5 is 10. And you can multiply these out. Let me see if I can focus it. You can multiply these out because they're both whole numbers. What about this one, 81? So we'll check our perfect square list. Right here, the square root of 81 will be 9, because 81 is a perfect square of 9. We still have to deal with that negative 5. So we have negative 5 times 9, which is negative 45. Like I said, we can kind of check our answers. If I do negative 5 times square root 81, it gives you negative 45. 169 is not on our list, but if we had kept going, 11 squared is 121, 12 squared is 144, 13 squared is 169. 169 is a perfect square. It's one that students usually forget, but it is the perfect square of 13. And like I said, if you don't believe me, you can always use your calculator to double check. The square root of 169 is 13, because 13 times 13 is 169. We still have the 2 in the front. 2 times 13 is 26. And you could have checked by doing 2 square root 169, 26. Very cool. Now, these were all cases where they perfectly were all perfect squares. 4 is a perfect square. 25 is a perfect square. 81 was a perfect square. 169 was a perfect square. Now let's talk about the cases where they're not perfect squares. For example, 50 is not on your list. It's close to 49, but not quite there. So remember from last class, what you want to do is you want to factor it, but not only do you want to factor it, you want to factor it so that it has the perfect squares. So if we think about 50, we have 1 times 50, 2 times 25, not 3, and we have 5 times 10. So if we look at these, you can notice, hey, 25 is a perfect square. So this is what we're going to want to factor it out into. So square root 2 times square root 25. And we still have this 3. Now, don't multiply these out again. I'll give you back 50, but we don't want the 50. The reason we did this is because square root 25, well, 25 is a perfect square, so we can simplify it to just whole number 5. Square root 2 is not a perfect square. Be careful, we do have 2 squared. 2 squared is 4. So these are perfect squares, 1, 4, 9, 16, 25. So 2 is not a perfect square, so it's going to stay as square root 2. And I can bring down the 3. So this is where it gets a little complicated, so if you're a little lost, that's okay, we'll do more problems. Now, whole number multiplies. So 3 times 5 is 15. There's only one radical, so it's going to stay 15 square root 2. Now these you can still double check your answers. If I do 3 square root 50, it's not going to give me a whole number, but I can check to see if this gives me the same decimal back. 15 square root 2. Notice they're the exact same decimal. Whereas if I have done something incorrectly, it would give you a different decimal. So you know you did it correctly when your original problem and your simplified answer are the same. For number 6, 27 is once again not a perfect square, but we're going to try to find perfect squares. What I usually like to do is say, okay, which of these numbers will go into 27? If you're not good at factoring, remember, we learned last class that you can just take your number and divide it by x. And then do Control T, and here's your factor list. 1 times 27, 3 times 9, 3 and 9, 9's a perfect square. Decimals don't count, and when you get a repeated number, like 9 and 3 and 3 and 9, you stop there. So we're going to do, something that might make it easier is also put the perfect square first. So square root 9 times square root 3, and that negative 2. Square root 9 is just 3. Square root 3 stays square root 3, won't simplify. You can also see that. Square root 3 does not simplify, whereas square root 9 will give you a whole number. So that's why we leave square root 3, but square root 9 becomes a whole number. Then you have the negative 2. Now here are my whole numbers. Negative 2 times 3, which is negative 6, times square root 3. And that's your answer. You could double check it, put this in your calculator, and then put this in your calculator, see if they give you the same decimal. But I'm going to start going a little bit faster. So we move on here, 28. So if I look at my factors of 28, I can see I have 1 and 28, not a perfect square. 2 and 14, not a perfect square. 4 and 7, 4 and 7. 28, 4 and 7. 4 is a perfect square. Oops. So we can. Remember, always try to put the perfect square first. Square root 4, square root 7. Remember, these will stay square root because we haven't simplified yet. And then my negative 3. And these are all being multiplied. Now, square root 4 just simplifies to whole number 2 because square root 4 is a perfect square. Square root 7 stays as square root. It is not a perfect square. Times negative 3. These will multiply to give you negative 6. Square root 7. 192. 192 might be a more tricky one because that might be one that you don't have all the factors memorized. That's okay. We can just keep doing this in our calculator. 1 and 92, 2 and 96, not a perfect square. 3 and 64, ooh! 64 is a perfect square. But you might say, but Miss, what this? 4 is also a perfect square. So which one do I use? Do I use 4 or do I use 64? You always want the largest perfect square. So even though 4 is a perfect square as well, we want to use 64 because we want the biggest one. But let's keep looking just in case. So 3 and 64, 4 and 48, 6 and 6, 32, still not a perfect square. 8 and 24. Not perfect squares. 12 and 16, none of those are perfect squares. 16 and 12. Notice we started repeating 12 and 16, 16 and 12, so we can stop looking. Our biggest perfect square was here, the 64. So 3 and 64. So I'll write my perfect square first. Multiply them out. Square root of 64 is 8. Square root 3 stays square root 3. And you bring down the 4. 4 times 8 is 32. Square root 3. Here's where it gets a little bit harder. So we've learned how to just simplify with single term radicals, but now what if we start introducing the multiplying? So we'll start like normal. You can say, okay, well, we have a square root and a square root. These will multiply. So you'll get square root 60, and there's only one number that's a whole number. So 7 square root 60. But you're not done. You have to double check, okay, will 60 simplify like you did in these problems? So 60 divided by x. Control T. 1 and 60, 2 and 30, 3 and 20. Ooh, 4 is a perfect square. 4 and 15. 5 and 12, 6 and 10. Ooh, 10 and 6. 6 and 10, we're done looking. Our biggest perfect square is 4 and 15. So square root 4 times square root 15. These get multiplied. Square root 4 is just whole number 2. Square root 15 will stay square root 15. 7 is still whole number. 7 times 2 is 14. Square root 15. These are as hard as radicals will get because not only do you have to multiply, but then simplify. So let's try again. 15 and 12. Well, we'll do 15 times 12. And we can multiply these two because they both have the radical, which is 180. You're 10. Check to see if 180 is a perfect square. Let's keep going. 14 squared is 196. 15 squared, oops. is 225, too high. So it is not a perfect square. So we have to find all our factors of 180. 180 divided by x. Control T. 290. 90 is not a perfect square. 60 not. 4 is a perfect square. Now we have to see if there's any bigger ones. 36 is a perfect square. It's right here. So we already eliminated 4. 36 might be our biggest one. 6 and 30. 9 and 20. 10 and 18. 12 and 15. 15 and 12. Since we repeated, we're done. So our biggest perfect square was at 36. 5 and 36. And then you bring down the 10. Square root of 36 is 6. Square root of 5 will stay square root of 5, and 10, which will give you 60. Square root 5. Once again, you can check your answer if you would like to. Square root 12 times 10 square root 15 is about 134.164. And then 60 square root 5 is the same decimal. So we did simplify correctly. So we have 72 times 6, which is 432. And then, oops, almost forgot my square root. 3 times 2, which is 6, because these are the 2 whole numbers. Ooh, this one's going to be a lot of factors. It's quite a big number. 432 divided by x. Control T. 4 is a perfect square. Ooh, 144 is a perfect square. It might be our biggest one. That's a really big perfect square. So even though 4 is 1, it's too small. 6 and 72, 8 and 54, 9 and 48, 12 and 36, 16, 27. 27 is not a perfect square. So we haven't seen any bigger ones. 36 is a perfect square, but 144 trumps it. It's bigger. 18 and 24. 24 and 18. We repeated. 24, 18. 18, 24. We can stop looking. So 144 was our biggest perfect square. And it was here we go. 144 and 3. Square root of 144 is 12. Square root of 3, say square root of 3. And 6. 6 times 12 is 72. Square root of 3. 72 square root of 3. Last one, 28 times 3 is 84. Square root 84. Now that looks like 64, but it's not 64. So we still have to look for perfect squares. Oops. 84 divided by x. Control T. Let's see. 4 is a perfect square, so maybe 4. No. 12 and 7. 7 and 12. So we repeated. So our biggest perfect square is 4. So square root 4, square root 21. This time we don't have any whole numbers out in front. So it's just going to be these two. Square root 4 is 2. Square root 21. And that's it. That's your answer. 21 won't simplify to anything else. That's a perfect square. So these are your notes. If you still need more help or more practice, feel free to ask your teacher or sign up for tutoring. Otherwise, have a nice day.